The future of technology is not in our hands but in our minds, and we are closer than ever to merging the human brain with computers. The brain computer interface technology about which we are going to learn today is going to play a very crucial part in this journey. What is a brain computer interface? A brain computer interface (BCI) is a system that allows communication and interaction between the brain and external devices such as computers or other electronic devices. In simple terms, a BCI enables users to control devices using their thoughts and brain activity only. How do BCI systems work? They work by recording brain signals using sensors that are placed on the scalp or implanted in the brain, and the computer reads these signals and finds patterns to understand what the user wants to do. And finally, the process signals are converted into commands that control a device. So first the brain signals are recorded, then they are processed, and finally converted into commands that can control a device. Some ways in which brain signals are recorded in BCI are as follows. Electroencephalography or EEG record electrical activity in the brain using electrodes that are placed on the scalp. The magnetoencephalography or MEG detects magnetic fields that are produced by electrical activity in the brain and gives detailed images of the brain function. The electrocorticography or ECOG involves placing electrodes on the surface of the brain to record brain activity with more detail and accuracy. The functional magnetic resonance imaging or fMRI measures blood flow in the brain to indirectly get the neural activity. The two main types of BCIs are invasive BCIs and non-invasive BCIs. Invasive BCIs require electrodes to be implanted into the brain, directly into the brain through surgery, and they provide high accuracy and better signal quality. But the risk is that they can cause infections or tissue damage. Some examples are electrocardiography, where electrodes placed directly on the exposed surface of the brain record electrical activity from the cerebral cortex. Then the microelectrode arrays, which are devices that contain microelectrodes through which neural signals are obtained, essentially serving as an interface that connects neurons to electronic circuitry. Non-invasive BCIs are placed outside. The electrodes are placed outside the skull or on the scalp. They are safer but less accurate due to the weaker signals that are produced. And the benefit is that no surgery is required, and so no particular risks are involved. Some examples include electroencephalography. In the small sensors are attached to the scalp, and these pick up electrical signals that are produced by the brain. Then there is the functional near infrared spectroscopy or FNIRs that use near infrared light to measure the brain activity. Some applications of BCI are as follows. First one is to make prosthetics and assistive devices. Mind control prosthetic limbs for amputees is an example. Another example is assistive communication devices. People with disabilities like ALS, which is amyotrophic lateral sclerosis, or paralysis can use BCIs to control computers, type messages, speak through a voice synthesizer, etc. Then there are brain control wheelchairs, where users steer wheelchairs using only their thoughts, and with individuals with mobility impairments, they can use BCIs to operate the lights, doors, appliances, etc. in their home without any physical effort. And in patients with stroke or spinal cord injury, BCI therapy is used to regain movement by stimulating the brain muscle connections. The second category is communication and computer control. Here, the various communication technologies are involved. So, there is brain control typing. BCIs will help users to type on screen using their thoughts, enabling communication without any physical movement. Then there is speech generation, where BCIs can translate brain signals into synthesized speech. And there's computer navigation, where people with ALS or locked in syndrome can browse the internet, send emails, and control devices using brain signals. The final category is virtual reality and gaming. There are many companies that have put forth devices using BCI technology. Neurable is an example. The company Neurable developed the first brain controlled VR game called The Awakening, where players use their thoughts to interact with objects in the game. Then there's Mind Maze, that uses both BCI and VR for neuro rehabilitation, where stroke patients are helped to regain their movements by engaging in thought controlled virtual exercises. Then a company called Next Mind made a wearable BCI device that allows users to control VR interfaces with their thoughts. Here is an example of BCI being used to control a robotic arm. This is a study that was conducted in Stanford University, where a person with ALS was connected to a BCI device that converted their brain signals into speech. This is Neurable unveiling their first brain controlled VR game. Even though BCI is a technology with wide scopes, there are still limitations and challenges to it. The first one is signal variability and noise. Brain activity is very complex and can be affected by various factors. So, most of the times, the brain signals may not be accurate. That's what the second point's about. There's only limited control and accuracy with the PCIs that are currently being offered, and more advancements are still to be made. Lastly, there are ethical and safety concerns, because with invasive BCIs that require surgical procedures, ethical issues are being raised, and with non-invasive methods, it can be uncomfortable or require training. So, to talk about the future of brain-computer interaction, BCI is actually changing the way we interact with the world. So, from helping people with disabilities communicate and control devices to creating immersive gaming experiences, PCIs have endless opportunities. As technology advances, PCIs will become more accurate, accessible, and integrated into everyday life. While challenges still remain, the future of BCI is still full of exciting opportunities that could improve lives and reshape how we connect with technology. Thank you.